When we're thinking about the inverse of a matrix, first thing we need to think about is the determinant. So the determinant is given to us in this formula, and to use this formula you'll need to label the elements in your matrix in this order, A, B, C, and D, and then simply taking these numbers in this order, A, D minus B, C, and then you'll get a number out of it. So what's important about the determinant is that if the determinant is 0 for a matrix, it does not have any inverse. So many questions will ask, does this have an inverse? And it's asking you to find the determinant. Now, obviously you can do it by hand, but there is a function on the CAS. So this one is simply about the determinant. On both CASs, there is a function where it'll give you the determinant right away. So please try this one out with the CAS that's next to you. And then after you have the determinant, here are the steps to find the actual inverse of the matrix. So if we have a matrix, we write them in this order, A, B, C, D, and then you want to swap them. So you're swapping A and D, and then you are going to multiply -1 to C and B. So you end up with this. So D here, A here, they're swapped. And then there's a negative in front of B and C. And then what you do after that is once you have this, you're going to multiply that with this fraction. And on the bottom of the fraction, you have the determinant. So in essence, you are finding the determinant, put it over 1 over determinant, times that with your original matrix, but these two numbers are swapped, and then these two numbers are now negative. Obviously that's a lot of work. You can do that simply on the CAS, and that's just writing your matrix and then taking it to the power of -1. You have your matrix to the power of -1. Right away, it's going to do all this work for you and spit out the answer. The CAS will do that all for you. Now, what's special about the inverse is that if we multiply the inverse and the original together, we always end up with the identity matrix. So that's just one with the 1s here and 0s everywhere else. And another way the inverse is really useful, if we were ever to find, say, x here, so we got A times x equaling B, you might know that, well, in algebra, let's say we have ax minus ax equals b. To find x, you know to divide both sides by a to have x on its own. It's like that, but a little bit different with matrices. You're not really dividing them, but you are getting rid of this a so that you can have x on its own. You're solving for x. But once you get rid of it, it's going to be the inverse of that on the other side. So we can use inverse in that sense as well. So let's do an example here. So we got our matrix A, matrix B, and then we're solving for the unknown matrix F if this was the case. Again, we want to get rid of this A by bringing A to the other side, but it's now the inverse of that. And to find it, you simply in the calculator do the inverse of A, so write this down, put it to the power of -1, times all of this. So if you simply just put that in your calculator, it's going to give you the answer. So try it out yourself, see what you get. You should get this, 3, -4. So that's the answer. And this next one here, we're looking for x, so you do need to get rid of a. So now a is going to be the inverse of a on the other side, and this time you're multiplying it with this matrix here. Again, put that into the CAS, you should end up with a 4 and a 1 like that. Now, lastly, we're going to put a little bit more algebra into this. Use it to solve simultaneous equations. So simultaneous equations, when we have two equations and two unknowns, just like this one. Now, first thing you need to make sure of before you do anything is make sure your x and y's line up. So you can't have x first and y second in first equation and then y first and x second in the second equation. As long as they line up and there's only a number on the other side of the equation, you are ready to put these into bunch of matrices. It goes like this. So you take the 2 and then you take the 3, take the 4, take the -6, make sure you're taking the sign as well. And then you're going to put x and y, because we put x first and then y second. If it was the other way around, we'll put it the other way around. And then on the other side, you do the numbers that's on the other side. Now, you can just put this into the CAS and use the solve function for solving x and y, or you can use the inverse that we just learned. So we're solving for x and y. So you're going to get rid of this bit here by bringing it to the other side, but as an inverse, and then multiply with whatever was already there. And then that's going to give you x and y for you. So try it out and then see what you get. Alright, so hopefully this is what you have. I ended up with this. So I've got, actually I'll do like this. Now I got 1 and then 4/3. So because we put the x on top, the number that's on top is correspond to our x value, and then the number on the bottom corresponds to our y value.